All right. So, where's this test start?
Chapter 8.
Yeah. What was that all about? Confidence intervals. I like it. Kick ass. Chapter 9 is about hypothesis tests. So we start with the 5 formulas we learned in chapter 8. Oh my God, somebody really writes hard. Okay. Oh well, let's live with it, Jeff. So the 3 formulas for creating confidence intervals. Notice there are 2 for means, right? What's really nice about those 2 formulas based on something you're supposed to know? No, not necessarily. When do I use z-scores? When I know sigma. And when do I have to use t-scores? When I only know s. And of course, to use either one, I have to know that it's normally distributed, the sample means. Yeah. And how many confidence interval formulas are there for percentages? Just 1, because I only ever use z-scores with them. It's either z or nothing with them, right? So, P little hat dude. Become a cube, or my approximation of a cube. All right. Why is everybody in that formula, all the P's and Q's, why are they all wearing hats? And with that here today, no, huh? Yeah, because we only know sample information. In a hypothesis test, we assume that we know the population percentage. So that's why in hypothesis testing, there's no hats on the P's and Q's that are in here. There's only a hat in the one representing our sample findings. Okay, maybe. And you're all like, that's great, Jeff. You said a bunch of words. Keep going. Okay. So then there's 2 more formulas from that section that deals with how to find how large of a sample you need to take if you know how close you want to be, right? So there's this guy, the sigma, become a sigma. Wow. And then there's the one for percentages. All right, so that would be if I ask you a question, how large of a sample would you need to take to be within, it's one of those 2. That's right. That's chapter 8. And then we get into chapter 9, which actually brings back some old stuff that we've worked with before. It brings back this guy. And alternately this guy. Let's put a little star there. Star. Let's make it T star, Jeff. Become a minus. All right. Remember that I had those 4 formulas up on the board and we did that last quiz. But then we get into hypothesis tests for percentages. And of course, that's a new thing. Like a lot of new things, it just reuses old things. So this, when we do percentages, I've got to do my sample minus the supposed true thing divided by the spread, which we steal from the confidence interval formula. Not a good thief. I'm announcing what I did. It's probably, in general, not good. It'll get you impeached and shit. Let me think. Is there anything else from chapter 9? I don't think so. Anybody else? You can if you want to. We talked about chapter 10, which is extra credit. So if you missed that, section 10.2, I think it is, I assigned.
Is the homework credit?
Huh?
Is the homework
Is the homework?
is extra credit too?
Yes. That's the idea. So 10.2, chapter 10, whatever assigned is extra credit. There will be one problem on the test in the bonus section related to that. So you do not have to do that homework if you do not feel like it. That homework.
Can you do the homework for the chapter 10, 93?
Sorry?
Can you do the homework, like 93 in chapter 10?
No. Sorry. That's bonus. So if you want to ask me in my office hours, fantastic. But I'm not going to take up time because that's not something I'm going to test you on. It's a bonus question.
No.
So I will answer it, but I'm not going to waste this class time. It's an extra credit. Right? So if you have a question about a problem in the extra credit section, you got to come see me in my office hours. Yeah. Okay. So if you want to, now if you did not and are not going to do chapter 10, don't write this down. So we developed that last time, that formula, but didn't really go too deeply into it because it's extra credit, so it's really up to you. Okay. All right. Anything else? Any other suggestions on what to put on your formula sheet? I have been known to say yes to suggestions sometimes. More often it's a no, but still. No? You guys are all cool with just that? You could bring in your previous formula sheets if you want to. Probably don't bring any that you lost points on. Maybe rewrite those. I've had people do that. So I'm like, okay, I already know how many points to take off because I did it once. Yay. Okay.
For the N one, is it the same for T, or do you need?
Yeah, to be honest, sure. If you want to, you could put this down. There could be another N1 where it's T squared, S squared. If I don't know sigma, I use S, and if I use S, I gotta use T. So it really is the same formula. See there? I said yes to suggestion. That's crazy. Okay, all right. So that's it for that. I can open it up to whatever you guys want to look at. I have a specific thing I want to look at some point, but I want to go with you guys first. Questions from homework, questions from the quizzes that you just got back. You can be working on those corrections. Questions from the practice test. I know I've got the answer key, but who cares? It's going to be a really short class. I brought one thing. I can do my one thing, I guess. Yes?
Oh. So the S is this individual?
Yes.
And then the other one is to find the sample, or the?
No. Okay, let's get this right. Sigma and S both stand for standard deviations amongst individuals, how spread out individual values are. One of them is population, one of them is sample. But still, they're for individuals in the population or individuals in the sample. When I take a sample, let me see if I can get this. When you take a sample, you can calculate S, correct? I take a sample of values. Can I calculate S? Throw them in one bar stats, get S, right? You're all like, yep. So, why do I need to do that little formula? Because when I take a sample to test a claim, I am comparing that sample to all other possible samples. I'm not working within that sample, I'm comparing that sample to all other possible samples. So I need to know the spread of all samples. And that's what that little formula does. It gives me what the spread would be for all samples of size n. So if I took a sample of size 40, this is the question students really hate. But oh well. If I took a sample of size 40, is that sample normally distributed?
Yes.
No, it isn't. I don't know, it could be. If I took a sample of 40 grades and they were all 73, every single one of them, is that normally distributed? What does it mean to be normally distributed? Can you draw it for me? Okay, that would be normal, right? If they were all 73, what would that look like? No, this, right? There's 73, bleh. Does that look normal? Okay, really, stay with me now. Come on. So I don't care. Anytime I take a sample, I don't have a flipping clue. If I draw it, I can see what it looks like. There is no theorem about certain samples will definitely be normally distributed. No theorem says that. But if I take a sample greater than 30, right? I don't know what the hell that individual sample looks like, but all samples, if I plot them, will be normal enough. If I took every possible sample and plotted them, it would end up being normal enough. So any individual sample I take, what could it look like? Any freaking thing. I don't know. Sample of size 18 billion. Will it be normal? I don't know. But would all samples of size 18 billion be normal? Yes, they would. Because that's way over 30. This is what I was talking about. You might want to rewatch the thing about the ages in Florida thing. Maybe. All right. I don't know. Can you pass this class without really understanding what I just said? Yes, you could. Would it be better if you understood what I just said? Of course it would be. Yeah. So what do you have to do first in number 3? Put them all in, well, there's 2 groups. So I don't want to put them all in L1. Yeah, you could do L1, L2, you could do them one at a time. So in number 3, you do have to take, like, the people that pass the class, put their hours spent studying into list 1, figure out the X bar and the S. Then you got to do it for the next set of data. You could put that in L2 if you want to. You can clear L1 and put them in, whatever the hell you want to do. Yes, no, maybe so? Yes?
How do we know if they or these?
For that one? Where is your standard deviation coming from? No. Did they give you the population standard deviation anywhere? No. And those 2 things, what are they? Are they populations or samples? They're samples, I say so, right? So the standard deviations you are getting are coming from samples. Therefore, you have to use t-scores, yeah. What else do I know, though, that lets me do something in the first place? Yeah, they're normally distributed, so it doesn't matter how big my individual samples are, the population is already normal. Let me see, let me ask you, is that cool? And again, sometimes you're just going to have to sit and think for a second, where did that standard deviation come from? Was it a sample or a population? That's what tells you Z or T. And sometimes, again, I still get people saying, I know the standard deviation, so I can use it. No, what? Which standard deviation do you know? Right? So let me ask you this. This is going to seem silly, but oh well. Right? You're all like, that's all you freaking do, John. But if I took one person and found their shoe size, is that one person normally distributed? Very weird. What the hell are you talking about? How could one thing be normally distributed, correct? But if I took 80 shoe sizes, could they be normal? Yeah, if I plot them, maybe they are normal. Do they have to be normal? No. They could look like whatever the shit, 80 people's shoe sizes, right? If I took one sample of 80 people's shoe sizes, is that normally distributed? That makes just as little sense as saying, is that one dude normally distributed? That doesn't make any damn sense. Is the population of all groups of 80 shoe sizes. Is that normally distributed? Shit, yeah. Why? The population of all samples of size 80 shoe sizes, are they normally distributed? Hell yes. Why? Yeah, the sample size is more than 30. An individual sample can look like whatever the hell. It can look weird as shit. But if it's bigger than 30, that means that if I did every sample of that size, it would come out to be normal enough. All right, that's the last time I tried to tackle that one. It sort of came off with this other thing, so I figured I'd try one more time. You giving up, Jeff? Yeah.
But how do we know it's 1 tail to this?
Okay, so now you want to transition. Everybody's got these? No? Have you got this side? Yes, okay. Which one of the hypotheses sets up the rejection region? I'm wondering if anybody's out there is like, why did I put myself in a situation where I'm supposed to understand that phrase he just said? Which one of the two hypotheses sets up the rejection region? The alternate, the high. That's the one I can show evidence for. It tells me where I could go to find that evidence. So if the H1 was something like this, is that a 1 or a 2-tail test? 1 tail. Right? In fact, it would be a left tail. Right? What would the high have to be so it would be a 2-tail test? That would be a 2-tail test. Not equal to, not equal to. Right? Not equal to. H1 has to have the not equal. Because the ho has the equal. Yeah. You guys doing all right? Oh, okay. Let me say a couple things. If you are like in a situation, and this is not true for a lot of people, but there are a few people this is true for now, where it's impossible to pass. I'm not saying there's some in this class, I just know in my classes there are a few people where it's mathematically impossible. I don't give enough extra credit on the final for somebody to pass. Are you with me? I mean, I'm just going to be, I think you know I'm a little blunt as a person, but oh well. Right? If you are in that situation, what you need to take away from this is what the hell did I not do or take advantage of that next time I take the class I can take advantage of, right? A few of you guys have come to my office to see me. Some of you guys have not. I'm not saying everybody needs to. I'm saying that more people probably should have, right? And you're all like, come on, dude, don't come on. Tutoring center. I understand that some of the tutors might have some issues with some areas of statistics. Well, then you fill in an evaluation, you find a tutor that understands that area, and you work with them. But you still go get help. You understand what I'm saying? Yes, yes. So some of you guys are not in a situation where it's impossible. It is possible, and a lot of you guys are doing fine. I don't want to make it seem like everybody sucks, but a lot of you guys are doing just fine. You got to keep it going. But some of you guys are in a situation where it's not impossible to pass. It's just really difficult. But the nice thing for most of you people in that situation, you can identify things you have not done. That if you start doing them immediately, you should improve enough to pass. Like homework, I don't know. Actually doing the homework. I love, some of you guys know the English thing that doesn't work so well anymore where you can paraphrase something. You can, I love it. It does not work in math. Where you see something in somewhere and you copy it, but you change the order of things. I mean, give me a break. You all know this. I knew this as a student. It's still out there. In math, you do that shit, the result doesn't make any sense. It's really obvious you don't understand it. So when you're trying to copy something in math and you don't have enough of an idea, the result you put down is not going to make any sense. And I've had people come to my office and say, but I said the same thing the solution manual did. Well, okay, right there. that's bad, right? But no, you didn't. You turned around, so it didn't make any sense more. I don't want this to be only negative. I want you guys, you've got to take any experience you have in college. If you're going to fail a class, that happens. Shit. I definitely failed some classes. Holy shit. Right? Not because I was dumb, not because of any of that. I just had a lot of life stuff going on. Right? What you do is you analyze the things you can control and you control them next time better. Or you start right now controlling them. Right? You have control over more than what I think some of you guys think. And I love it. Some of you guys are like, no, you don't know. I do not think that word means what you think it means. But again, if you've never come to see me, I'm the one that's providing your notes. I'm the one talking about these things. I can tell what you've got wrong if I start talking to you. And very often you guys are going to feel like you're this far away from understanding, when you're really just this far away from understanding. But if you don't understand it, you have no idea how far away you are from it. Does that make any sense? I've seen this all the damn time. Someone's like, I don't understand these 80 problems. I'm like, it's because this is supposed to be this. Holy shit, now I can do this 80 problems. Anyway, okay, I don't know. So you have to identify, and I think I've communicated to you, the things that are available to help, right? And then you actually have to go use them. You with me? A little bit. Okay, sorry. So I cut somebody else off. Who had a question?
Oh, I was just, can we start in the
Oh, so did you do that in the one var stats?
Yep.
So let's do the passing first, right? So number 3, if you haven't tried it out yet, you should put those in the calculator and see what you get. What'd you get for the mean for the pass the class? Have you done that? I'm sorry.
Yeah, 7.631.
I like it. What about the standard deviation?
1.11.
You're closer. Almost, but of course standard deviation. Since you're taking crazy ass Jeff, you have to take it at least
4.
at least 3 places, but you could do everything 4. Cover your ass for everything, right?
Oh, yeah.
Oh yeah. That's one of my favorite. 1.146. Right? You guys should all be able to do that. One var stats. You are the human. You know what you're putting in. The calculator's stupid. It's going to give you both. Here you go. And we're like, all right, calculator, I got you. It's S because it's a sample. Don't say, oh, I know sigma. Yeah, no, you don't. It's a sample. You don't know sigma. All right. So what do I have to use? New and I were talking about this earlier. Right? What do you have to use, a T or a Z?
T.
2 things you got to tell me. Why can't I use a T score? It's the same. S is the only thing known. And? Yeah, normal given. Yay. Or stated. It was stated normal, or he said it was normal. I like it. So now that you've got those parts, what's the formula we're going to use? We have to still look this up, but so I got N, S, and X bar. I still need T. Once I get that, I throw it all in there. So let's see what we get for T. What's the degrees of freedom on this one? Degrees of freedom. What was N? You can get that from one var stats. 16, right? For pass the class, right? 16. So what's the degrees of freedom? 15. So what's the T score going to be? Alpha, I want to make a 95% confidence interval. So alpha in two tails is how much? For 95% confidence? 5% in two tails, so 0.05, yes.
I don't get where you got the 16 from.
Oh, well, there's 16 numbers, right?
Oh, okay.
Yeah. N always means the same thing, the amount of stuff in your sample. Or the amount of stuff I'm looking at, yeah. So if you go 0.5, two tails, that's the middle column, and then I stop at 15 because that's the degrees of freedom. What t-score do you guys get? 2.131. And then you just do that. Yeah. You do the exact same thing for failed the class. And yeah, I put public service announcements in my problems. Too bad. You guys get every element of what just happened. I know it's a confidence interval. So you could have, at the very beginning, you could have written this formula down, and the formula keeps you on track of what you need to get. I tell you nothing really. You got to put all the data in and get this stuff. So I get this, this, and this. I can throw those in. T comes, of course, from how confident I want to be, right? And it's not a Z because I don't know the population standard deviation.
So you would do that for each of the two sets
Yep.
of data?
You make a confidence interval for the first set, make a confidence interval second set, and then I'm going to have you compare the two to see what we can see. It would be evidence for something. Yeah. You got time?
Yeah, thank you.
I should wear a tinfoil hat on Wednesday since people in here can apparently read minds. So we discovered that last time. It's tripped me up. Anybody else not get their quiz back? Everybody got their quiz back? So you could be working on, we had those last two quizzes, you can work on those corrections, we got the practice test. You can ask me questions from any of that stuff. Yeah.
I have a question on the homework.
Yeah.
For chapter 9, 98.
All right.
So what's gonna be my alpha on that?
So I think this is one where at the beginning of the section, no, I guess somewhere in the chapter, what's the most commonly used alpha? Has this come up yet? Maybe the other class I made a big deal out of this. What was unusual before? It was two standard deviations away, right? Because there was 5%. So the most commonly used value for alpha is 0.05. So if the problem doesn't say, you use 0.05. Yeah. I thought for sure they said it somewhere here, but maybe it's in the chapter somewhere. I'm going to ask you guys a conceptual question real quick. how would you feel about whatever H1 says if P was 0.0002? With the P value, right? So this is P value. Make that clear. I've talked about this before. Does anybody remember what the p-value represents? The area in the... No, that's alpha. Alpha tells me what the rejection region is. Where's the p-value come from? My z-score, the z-star. So, if my z-star has a crazy small tail, right? Be jealous. It's got a crazy small tail. That means it is going to be really far away. So what p-value means is the probability that I got a sample where I did, given that this is correct. So assuming he's right, what's the probability that I would get a sample where I did? Well, in this case, what was the probability I would get a sample where I did? 0.02%. So that roughly is the probability that the null is correct. So what's more likely? The null's right and I just happen to get a weird-ass sample, or the null is wrong? Null is wrong. That's what's more likely. It's a very small chance. So the smaller the p-value is, the more likely H1 is correct. It's more and more evidence when p gets small. Because if I got a tiny, tiny tail, that means I must be very, very far away. And the whole idea of hypothesis test is I want a sample to show up really far away. This guy thinks it's here. I found something over there. Looks like this dude's wrong. Is that right? Did I answer that question? Did I over-answer that question? Yeah.
Can we do number 5 since it's one of the percentage ones?